Hello everyone, this is Mr. Appel, and we're going to look at solving a rational equation like this one. Rational equation is just an equation made up of fractions, where variables are in the denominator, where we have a polynomial, like we have here, over another polynomial in our equation, and sometimes more than once. Okay, so basically the first thing we want to do, similar to what we would do when we're just dealing with equations with just normal fractions, is to just kind of clear out the denominators first. Basically make it not be fractions anymore. And so if we multiply both sides of the equation by each denominator, the denominators cancel out and we're left with an equation with no fractions. So let's do that here. In this particular problem, the only denominator in the whole problem is that x minus 1. So we're simply going to multiply both sides of the equation by the x minus 1. So on the left side, the x minus 1's cancel, and we're left with x squared plus 6x minus 7. On the right side, we have 5x minus 5. And now we have a quadratic that we know how to solve. But it's going to get interesting because rationals are very special. So let's keep going. I'm going to subtract the 5x to both sides and then add the 5 to both sides. So that's going to give me x squared plus 1x. Negative 7 plus 5 is negative 2. And I'm going to go ahead and factor that. X plus 2 times x minus 1 equals 0. So x is negative 2 or x is 1. But wait, it's going to get interesting because watch. When we solve rational, it's always a good idea to check your work. But when we solve rational equations, it's really important. Because remember the goal. The goal is trying to find values of x that make this equation true. And if we plug in negative 2, we get negative 2 squared is 4, plus 6 times negative 2 is negative 12, minus 7, over negative 2 minus 1, which is negative 3. And so we end up with negative 8 minus 7. So up here is negative 15 over negative 3, which is in fact 5. So great, that works, no problem. But what happens if we try to plug in x equals 1? Well, I'm going to start on the bottom here because if we plug in x equals 1 down here, we're dividing by 0. And there is no way, no matter what happens up here, that anything divided by 0 is going to equal 5. It turns out it's actually 0 divided by 0. And so that's not true. It's something divided by 0, and it doesn't matter. No, it is. Sorry. 1 squared is 1. 6 times 1 is 6. 1 plus 6 is 7. 7 minus 7 is 0. But regardless, if the denominator is 0, it can't possibly equal 5. And so x equals 1 actually doesn't work. And we call that an extraneous root. An extraneous root is a root that works for the equation when you clear out the fraction, but it doesn't actually satisfy the original equation. So we could write this as our solution is x equals negative 2. That's our solution. And then our extraneous root is 1. And sometimes we'll list it this way. We'll say x cannot equal 1. Informative, I had you just, when I asked you what are the extraneous roots, I just had you write x is equal to 1. Basically, oops, I wrote negative 1. That x is equal to 1, so you're listing the extraneous roots. But on paper, you'll write it like this. That's all for now. Thanks.